Okay, thank you so much, Dr. Nurul. Dear presenters, good afternoon and salamu alaikum. I am Professor Hussein Al-Kayim from Mechanical Engineering Department, University Technology Petronas, and I am going to chair this session. And in fact, my right hand is going to be Dr. Nurul. She will assist in the management of the session and the presentation and Q&A. So we have 5 presenters proposed to be in this session. And the first presenter is Sayyid Zulfikar. His paper is on elastic constant prediction using multi-scale homogenization of 3D fiber reinforced composites. So now I am inviting Mr. Said to present his research findings. Thank you.
Respected professors and audience, Assalamu alaikum and very good day. My name is Syed Zulfikar Hussain and I am a PhD student in the Department of Mechanical Engineering, University Technology Petronas, Malaysia. The title of my paper is Elastic Constant Prediction Using Multi-Scale Homogenization of 3D Fiber Reinforced Composites. So the outline of my presentation is listed here. I will talk about what is 3D composites, multi-scale modeling, prediction of elastic constants, comparison with experiments, and conclusion. Fiber reinforced composites are broadly divided into 2D and 3D fiber reinforced composites. 2D fiber reinforced composites, fibers are aligned along only in x and y direction. Thus, they exhibit excellent in-plane properties. However, they are poor under transverse load. Whereas in 3D fiber reinforced composites, fibers are aligned along all 3 directions. Thus, they exhibit excellent out-of-plane properties, which are very important in the case of impact. Now, the multi-scale homogenization of 3D fiber reinforced composites. The elastic constants of 3D composites depends on the elastic constants of constituents and their arrangement in 3D fabric architecture. These elastic constants can be determined analytically or through finite element analysis using multi-scale homogenization. The multi-scale homogenization is further divided into micro and meso homogenization and meso to macro homogenization. In the case of micro to meso homogenization, we determine the elastic constants of impregnated yarns and fiber and matrix properties, whereas in case of meso to macro homogenization, the elastic constants of 3D composites were determined using elastic constants of impregnated yarns and their volume proportions in representative volume element. So here we are considering 3 different scale levels. Number 1 is the micro level, which means that we are talking about individual fiber and matrix in impregnated yarns. B, meso level, which means that the impregnated yarns and matrix in RVE. And the final, the macro scale, which means that the autotropic material at macro level. So in this paper, these elastic constants are predicted using both an analytical and numerical method and compared with experiments. So at macro level, the 3D composite is considered as orthotropic material. Using multi-scale modeling, we can predict all the 9 elastic constants of these 3D composites. So these elastic constants can be used in the macro scale finite element analysis of these 3D composites under different mechanical loads. So now the 3D fabric used in this study is 3D orthogonal e-glass woven fabric, which is obtained from Textile Industries, United States. The fabric consists of 3 layers of fibers along warp or X direction and 4 layers of fibers along fill or Y direction. The dry fiber volume fraction of this fabric is around 52% and it has 49% yarns along warp and fill direction. So now in case of micro to meso homogenization, the analytical method used here is based on Chamish model, which required elastic constants of fiber and matrix and their fiber volume fraction in impregnated yarns. The elastic constants of e-glass fibers and epoxy matrix is summarized in the table on the left, whereas The fiber volume fraction of impregnated yarn is estimated based on the weave parameters of 3D fabric, which is tex count. The tex count is the linear density of yarns in grams per kilometer. The estimated fiber volume fraction along with their tex count is listed in the table. Whereas in case of a numerical method for elastic constant prediction of 3D composite is based on the periodic boundary conditions. The periodic boundary conditions are applied on the unit cell model of impregnated yarn. So the unit cell model is assumed that the fibers are arranged in hexagonal packing in impregnated yarn, whereas the dimension of unit cell is determined based on the radius of individual fiber and their relationship between the geometric dimensions. The periodic boundary conditions were applied in the form of 6 load cases, 3 normal and 3 shear. In each case, displacement load was applied to get respective reaction forces, and these reaction forces is then used to determine the compliance matrix. So once we know the compliance matrix of unit cell, the stiffness matrix of unit cell is determined by taking the inverse of compliance matrix using equation A. So from the stiffness matrix, all the elastic constants of impregnated yarns were evaluated using equation set B. So the table on the right shows the comparison of elastic constants predicted through analytical and numerical method. The values estimated by the numerical model is more accurate because we can apply pure shear in finite element analysis. So now measure to macro homogenization required details of representative volume element or RVE. The RVE is the representative unit cell of 3D fabric at macro scale. So the geometric parameters of RVE were determined using digital images obtained from a digital microscope, which are summarized in the table. These geometric parameters are used to evaluate the volume proportion of each constituent in the RVE. So now in case of measure to macro homogenization, the analytical approach is based on the volume averaging method. So in this method, the elastic constants of impregnated yarns, matrix, and their volume proportions are used to estimate the elastic constants of 3D composites. So the overall flowchart of the volume averaging method is shown on the right. It consists of 3 main steps. In the first step, the elastic constant and respective stiffness matrices of impregnated yarns were determined in local coordinate systems. In the second step, the stiffness matrix are then transformed with respect to their orientation in the RVE to get stiffness matrices in global coordinate system, which is XYZ. And finally, the volume averaging method is applied to estimate elastic constants of 3D composites using transformed stiffness matrices and their volume proportions. So the volume proportion of each constituents were determined using geometric parameters discussed earlier and RVE dimensions using equation set A. So the volume proportions are obtained. The volume proportions which are estimated are summarized in the table. The RVE contains 52.5% matrix volume and 74.5% impregnated yarns volume, and it is assumed that there is no voids in the matrix. The compliance matrix of constituents were determined by multiplying their respective volume proportions with compliance matrix given by equation B. So finally, the volume averaging method is applied to determine the compliance matrix of the whole RVE. So once we know the compliance matrix, we take the inverse to get the stiffness matrix, and from the stiffness matrix, we evaluate all the 9 elastic constants of 3D fiber reinforced composites. Now in the case of numerical method, similar to the micro to meso homogenization, the periodic boundary conditions were applied on representative volume element discussed earlier. So once we know the compliance matrix, the stiffness matrix is determined by taking its inverse. Here the elastic constants are determined in global coordinate systems which is XYZ. So now the comparison of predicted elastic constants with experiments. The elastic constants of 3D composites predicted using multi-scale homogenization are compared with in-house experimental results. The experimentally determined tensile modulus along warp and fill direction and shear modulus is compared with experimental values. The numerical model shows better prediction as compared to analytical model because it can accommodate more geometric variabilities and actual boundary conditions. The finite element analysis of 3D composites at macro scale required all the 9 engineering elastic constants, so the main purpose of this work is to predict these elastic constants and to reduce the number of tests. Now, conclusion. The elastic constants predicted by the analytical and numerical model matched well with the experiments. The elastic constant predicted by the numerical model shows better prediction and shows up to 6% deviation with experiments. The accuracy of predicted elastic constants depend on the geometric parameters of yarns, fiber volume fraction, and volume proportions of each yarn. These elastic constants can be used in the finite element analysis of 3D composites at macro scale. These are the selective references. Thank you. Yes, now I can hear you. Assalamu
Okay.
alaikum.
Wa alaikum assalam, Sayyid. Thank you for the presentation. Unfortunately, if we know that there are some other presenters are not joining, we can extend the session. So we give you a more flexible time to talk more about the topic. However,
Sure.
so far I haven't received a question from the audience or from the other presenters. So if you allow me to ask you, in your presentation, Said, you mentioned that this topic can be analyzed either analytically or by finite element technique.
Yes.
And now my concern about the validation. If you are using both of them, analytical, you need to validate. If you are using finite element, you need to validate. So what's about the validation of the result gained from those two approaches, please?
Yes. Actually, the main purpose of this work is to basically reduce the number of tests, number of experiment tests, as these 3D composites, they are orthotropic materials, and to predict the all engineering elastic constant, they required 9 engineering elastic constants. So we have to do a number of tests. So the main purpose is to reduce the number of tests. And so what we did, we did some, we predicted these elastic constant using analytical and numerical methods. And to validate these analytical and numerical method, we did tensile test and shear test. So the shear modulus and tensile modulus, which are obtained from those experimental results, are compared with analytical and numerical methods. So once these 3 properties are matched well, it means that
Yeah.
all the other properties are also matched well. So we don't need to do a whole list of tests to get these properties.
I get it. Thank you so much. And
Thank you.
in your presentation, have you included this comparison between your experimental test and the obtained results, or you postpone this to another paper or somewhere else? Because
Actually, yes, I have compared these predictions with the experimental result in the paper as well. Yes.
and the margin of error or the
And the margin error is around, I think, 6 to 8%. In case of shear, there is slightly higher variation that is predicted by the analytical model, because as you know that in numerical models, we can apply actual boundary condition, more actual boundary condition, and we can include more variabilities that are observed experimentally.
Yes, Sayed, you are correct. Because even if we got up to 15%, and sometimes when you have complicated simulation, up to 20% error compared to the experiment. If you ask me as a researcher, I said, okay, because the simulation, if you get 80% agreement, that's fine.
Yes.
If you go to 90% agreement, it will be better. So some
Yes.
people, that when they see the figure 15% error, they shock. This is logic. This is logic
Yes.
for me. I think it is logic because the simulation is complex simulation, and there are 9 unknowns. You are working on 3D. So once you go from 1D to 2D to 3D, more and more uncertainty are
Yes.
existing in the simulation. So
Correct.
what you did is correct. Thank you so much. If there is anybody else would like to ask, Said is open to answer. If there is no question from the audience or from Dr. Nurul, then we thank you so much for your participation in the training and your participation in the presentation, and good for you. Thank you so much.
Thank you. Thank you so much, Prof. I love it.
Yes, Noor. Noor, do you hear us, Noor, or your mic is okay? Nurul? Sorry, Noor. Noor. Noor, you are there? Okay, thank you. So our next presenter is Noor. She is from University of Technology Petronas, and she is going to present her finding from evaluation of NIRX network performance on the maintenance application of rotating machines. I wonder the rotating machine, including the pump or a specific item. Nurul is going to present to us, and we are going to interest in her presentation. So the audience is yours, Nurul. Norain.
Hi, Assalamualaikum. My name is Norain Muhammad Samsur, and I'm from University Technology Petronas. For today's conference, I will be presenting on the evaluation of NUX network performance on the maintenance application of rotating machines. This is the co-authors for my papers for this conference. Let's begin. So first, the introduction. We all know that standard maintenance, which is the corrective and preventive maintenance, it is not as effective as predictive maintenance. This is because they cannot actually predict the upcoming failure. Few important benefits by using the predictive maintenance is first, they can actually assess the machinery working conditions. Second, they could diagnose faults. And third, they could estimate when failure is likely to occur. Predictive maintenance approach by using the real-time data, which is they give a better understanding of the system degradation. Predictive maintenance is the combination of condition monitoring maintenance and the prognostic maintenance. There are 3 steps of predictive maintenance, which is first, data acquisition, second, data processing, and last, decision making. The aim of the study, which is to evaluate the artificial neural network prognostic model for a maintenance application of rotating machines. Prognostic models designed by the basis of non-linear autoregressive neural network with exogenous input, which is the NUX networks. Why are we using NUX? First, they can handle time series data in forecasting model network. Second, various researchers has provided with some noteworthy findings that could actually support the study. For example, the research made by Santoso in 2013 has managed to implement the neural network model, which is the NUX network, to monitor the health condition of turbo machinery in the industries. Next is the methodology. First step is data acquisition. This study uses NASA Center of Excellence data repository that are publicly available. The dataset is a simulated data using CMAPS, which is Commercial Modular Aero Propulsion System Simulations that operates with atmospheric model settings listed in Table 1. Table 1 shows the operational conditions of the engine simulation, which is the altitude, the Mach number, and the sea level temperature. Second step is data processing. The dataset actually contains 21 sensors measurement collecting different information related to the engine state at the runtime. However, not all the features contributed to the research variable, as some are constant throughout the time series, where some data are contaminated with sensor noise. Therefore, only 9 features are selected as input altogether with 3 operational settings and unit number. The selected features are assigned based on prognostic parameter choosing measures, which is considering the monotonicity, prognosticability, and the trendability of the option. Various evaluation from numbers of study on the dataset analysis has supported the findings where most common selected sensors are as Table 2. Table 2 shows the features selected as the input for the network training. The features are based on the overall census measurement of the engine simulations. And the last step for the methodology is the decision making. Table 3 shows the network configuration of the NUX network. The training function uses the Bayesian regularization, backpropagation, and the input and feedback delays 1 to 4. Size of hidden layers is 10. Data division is by using random distribution. Performance function is by using the mean squared error. Bayesian regularization helps to reduce the combination of squared errors and weights during network training. The configuration of artificial neural network model uses tensig, which is the hyperbolic tangent sigmoid transfer function in its hidden and output layer. Figure 1 shows the design of an open loop NUX data for the data training. The open loop configuration can also known as series parallel network mode. This mode can only be operated with the actual values of the targeted series to develop the target series regressor, and open loop mode is usually used for network training. And figure 2 shows the design of closed loop network. This configuration can also be identified as the parallel network mode. This mode uses response from the time series regressor to predict future values. We proceed to results and discussion. The MSE, which is the mean squared error for the test set, it is not far off from the train set. This condition signifies that there is no overfitting problem could occur. Figure 3 shows the MSE performance of the train network. The red line shows the performance of the test set, while the blue line shows the performance of the train set. The best training performance is at 0.009436 at epoch 35. Table 4 shows the score performance of the network training. Figure 4 shows the time series response of the network performance. Pattern of the graph is hinting at exponential growth. The interval beginning signifies an extensive working period within a specified point at the justified condition level, whereas the endpoint is the final limit of the machineries. For the research, the threshold limit is identified by the resulting value of training output series. The graph with the blue colored fit line, which is graph A, shows the training regression data, while graph B, which is the green colored fit line, shows the test regression data. Graph C, which is the red colored fit line, shows the overall regression data analysis. Last, the conclusion. The recurrent neural network such as NURBS is actually suitable for modeling the nonlinear system, and it is relatively good to model a dynamic time series data. Secondly, the interpolation within networks is actually possible as the system learns pattern of the incomplete data. This allows prediction to be made through interpolation with a low probability of error. Third, there is no overfitting problems could occur, making the network is reliable. Next, the model NUX network can be used for predictive modeling as the difference between MSE of the train and test data are actually small. Lastly, the feature selection has many benefits to a predictive model as it allows dimensionally reduction, permitting adequate and impactful sensors for the degradation models. Thank you for today, and I would like to thank the financial support provided by University Technology Petronas under Y2P grant, and also thanks to Mechanical Engineering Department with addition to the technical staff for their guidance throughout this research. Thank you for today.
Okay, thank you so much, Noor, for the presentation. And if there is any question from the audience, unfortunately, we don't have audience, and even our presenters are very limited. So if there is anything from Dr. Nurul or from Sayed, anybody else can ask a question? Okay. Noor, you are postgraduate or, sorry? Noor.
Postgraduate.
In which department?
Mechanical.
Mechanical? Because your, I can, Muhammad Yusuf Shah, your co-authors.
Hmm.
Who are your co-authors?
Dr. Tuan Muhammad Yusuf Shah and Shazatun.
Oh, Dr. Tuan.
Hmm.
They have written the name wrongly.
Uh,
Anyhow, so Tuan is your supervisor, and this is related to maintenance technology.
mm-hmm.
Am I right? Your presentation or your work on maintenance
Yes.
of rotating equipment.
Uh-huh.
Now, you are talking generally, or you have selected a specific rotating equipment like a turbine or pump or compressor, or what is it?
It's a general thing. But then for the study, it's using the turbofan,
Turbofan.
which is the CMAP simulation.
I don't know if there is any case study or side data collected to support this research, or from where you get the data for the.
It was
For
from the NASA training model.
Yes, please. Yes, go ahead, no, Dr. Noor.
No.
Yeah, okay, then. The question raised by Dr. Nurul, if there is any collaboration, because really this is industrial problem,
Mm-hmm.
and the industry looking for reduction of the cost of the maintenance,
Mm-hmm.
preventive maintenance or regular maintenance or whatever it is. So is there any collaboration with industry?
As far as I know, there's none of it.
Not yet.
Not yet.
Why don't you contact Petronas? I think the rotating equipment, also TMB. They have the turbines, they have the pumps, they have compressors. I believe that it is important to impose this on industrial application. If the software correctly produce for you a good maintenance strategy or a good maintenance policy. So what do you think from your notation, the result you obtained? Are you satisfied with the results of the software?
So far it's okay.
How when you said I am satisfied or confident, have you compared with another software or another existing application? I think you need to verify.
Okay.
When you said it's okay, then there is a need for verification. So look into this in the future. You need either real data or you contact the industry and collaborate with them. Otherwise, I don't think that you just get the result from a software and you said it's okay. Yeah. How are you going to evaluate the data of the simulation? Is there any experimental or site data or collected data from the industry?
No. But
Then what is the input? If there is no experimental data or site data, what is the input to the software?
I'm basing from the data I gain from the CMAP simulation, the one that I get from the the NASA website.
Well, in fact, we are talking about the research or the paper, so we cannot go more into your research, but we advise you, as Dr. Noral mentioned, that site data or experimental data is necessary to support either to input the experimental data or to compare your result with experimental data. So put this in mind.
Okay.
Yeah. And the best that you check with the industry and you try to get already acquired data.
Actually, there's another researcher that has done this kind of simulation, And I have compared with the paper, and my result shows quite similar to the paper. So I can assume that my result are on the okay part as compared to the.
Is he carried out by simulation or by experimentation?
If I'm not mistaken, both.
Both.
Mm.
Then you can utilize his experimental data. You can utilize his experimental data. But again, my concern that it is general. I suggest that if you be specific in selecting one rotating equipment and you apply your methodology. Thank you so much for the time and for the discussion. Appreciated.
Thank you, Dr.
Okay.
Everyone.
Abdullah, yes. Okay, so our next presenter, Abdullahi, is going to present on the effect of mesoporous nanosilica on the biocompatibility of poly-based composite for biomedical applications. Please show us the presentation. No video. Yes, please, let us skip this. And due to the, yes, please, due to the technical error in the record of the Abdullahi, we have to move to the next presenter, who is Aziz, Abdul Aziz. Abdul Aziz is going to present on deposition of biomimetic, biocompatible oxides on metallic glass surface by electrodischarge coating process. Electrodischarge coating process. Interesting, because a few days before I received paper from Indonesia on the coating process. It is another technique of coating. All right. So let us see, please.
Hello, everyone. My name is Abdul Aziz Abdul Aliu. I'm here to present our project or our paper titled Deposition of Biomimetic Biocompatible Oxides on Metallic Glass Surface by Electrodischarge Coating Process. Electrodischarge coating is an evolution of electrodischarge machining process. Previously, the process was developed mainly to cut difficult to machine material. As you can see here, this is a schematic diagram representing the complete EDM process. It involved the use of a tool and a workpiece, which should be immersed completely in the dielectric fluid. The basic working principle of this process involved the use of dielectric fluids and electrodes completely immersed in the dielectric fluids. Then the DC current is connected. So the connection of DC current resulted in the formation of an intense electric field. Then the electric field will keep increasing. The thickness of the electric field will keep increasing as the voltage is increasing. As soon as the voltage reaches the breakdown voltage of the dielectric fluid, which initially act as an insulator, then the spark will occur. This will result in the melting and removal of material from the workpiece material. In our project, we hypothesized that addition of the powder into the dielectric fluid will result in the melting of the powder and the powder deposited on the surface of the BMG. So EDM initially have been used. The use of EDM is widely been applied in the production of mold and dies, cutting tools, and are currently also used in aerospace and automobiles industries. but the use of EDM in biomedical field is still under experimental stage. The material which we adopted, which is called a bulk metallic glass, is an amorphous material, or we can say non-crystalline material, which have some unique properties when compared with currently used biomaterials like stainless steel, cobalt, chromium, titanium, its alloys, and magnesium alloys. This figure tries to demonstrate the relationship between the strength and the elastic modulus. As you can see here, this is the cortical bone. Most of the BMGs are much closer than to cortical bone in terms of elastic modulus. This will help in the stress distribution and avoid or prevent the effect of stress yielding due to much difference in the elastic modulus when conventional biomaterials is used. So we proposed this material due to its unique properties. BMG is also a newcomer in the field of biomedical, although the use of BMG to produce numerous components for automobiles, aerospace, and other components have been utilized. So the materials we used, as already previously stated, is a zirconium-based BMG, and we also adopted commercial pure titanium as electrode, and we accepted, we used hydrocarbon-based dielectric fluid as our fluid. And we use hydroxyapatite powder because of its biocompatibility nature, the powder to be added into the dielectric fluid. And the various characterization techniques will be used, will be employed to evaluate or assess the experimental results. As you can see here, this is the morphology of the this is the morphology of the as received BMG, which you can notice there is no any distinct grain boundaries. This helps in its unique property, that is, it do not allow easily dislocation to take place. So it have a very high strength compared to the currently used biomaterials, and also its biocompatibility is commendable. This is the SRD. As you can see, some white bumps here, which indicated that it is amorphous in nature and non-crystalline. These are the parameter setting which we used in conducting this experiment. And these are the EDX of the EDM'd, SRD pattern of the EDM'd material, zirconium-based BMG. As you can see, so many sharp peaks of the carbide, zirconium-based carbide, and some peaks of the titanium carbide, as well as zirconium oxide. The carbide might result as a result of reaction between the zirconium and carbon in the workpiece and the hydrocarbon-based dielectric fluids, respectively. While the oxide might be due to reaction of zirconium in the workpiece material, and oxygen might be due to flame, which occurred due to heating and melting during the process. While the HAEDM XRD depict the presence of some HA on the surface, and also some calcium-based zirconium-based oxide. The calcium might be from the HA powder, which is added into the dielectric fluids. And although there are some sharp peaks, but the crystallization, the amorphous nature is much higher than the crystal peak. This is the morphology of the HAEDM material. As you can observe, numerous porosities and craters and some few micro cracks. Porosities are really helpful in the biomedical implant, especially for the bone, because it mimics the surface nature of the bone, which contains some porous nature. And it also allows the tissues growth into the porous structure. This is the this is the magnified image. It is done just to check the force dimensions, especially the size and shape. This is another morphology just to check the layers developed on the HAEDM surface. As you can see, a thin recast layer, which is in the topmost, and also the oxide and carbide layer, then followed by heat affected zone, and then unmelted BMG layer. This is EDX just to confirm the elements and the compounds presence on the HAEDM surface. As you can see, the EDX confirm the presence of high peaks of calcium. This confirms that EDM process is a good process for depositing HA or for coating the surface of bulk metallic glasses. In conclusion, we can say that HAEDM can suitably be used to shape BMG without much influence on its crystal structure when proper parameter setting is utilized. And also, when 4 microseconds and 5 ampere discharge current and discharge time utilized, then the amorphous nature is much more maintained. The SRD characterization confirms the formation of zirconium carbide, titanium carbide, zirconium oxide, and other calcium-based oxides. And the numerous interconnected nanoporosities with diameter around 502 to 781 were also observed. The EDX pattern shows the deposition of some calcium-based oxide and some calcium elements on the machine surface. This further clarifies the suitability of EDM process as a coating technique of BMG material. These are some references which we used in this paper. And with this, I will say thank you very much for your listening and your time.
Okay, thank you for the nice work. It's really very good work, and the achieved results are industrial-based results. Very good presentation. Thank you. We are coming now to our final presenter, who's Mr. Icper Ps1. Icper Ps1 from University of Technology Petronas, and he is going to present on mitigation of chromium poisoning of the ferritic interconnect from annealed spinel of COFE2O4. Please.
Hello, my name is Muhammad Aqib Hassan. I am from Mechanical Department of University Technology Petronas. I am here to represent my paper entitled as Effect of Heat Treatment over Coated Metallic Interconnects of Solid Oxide Fuel Cells by Spinel of Copper Iron Oxide. Before starting my topic, I would like to introduce the SOFC. What is SOFC? It is an electrochemical device that works on the principle of redox reaction, so we can have a power and the water supply. So we can see that the oxygen atoms come from this and it oxidizes at cathode and travel through the electrolyte to reduce hydrogen atom at anode. As the result, we have a power and water supply. From this diagram, we can see that SOFC can give you 20 watt power to 10 kilovolt power. So if we want this power, so we need to place these cells in a series connection, and to combine these cells in a series connection, we need an interconnect material. So here we have an actual diagram of a fuel cell stack, and here we have a schematic diagram. So we can see that interconnect material is placed between two cells, two unit cells. This is 1 and 2. So if we want to place, if we want to combine the output voltage of these cells, we need to place this interconnect material. And for this interconnect material, it should have chemical inertness, electrical conduction, resistance to ionic resistance, and good thermal conductance. So if we want to place interconnect material, then it should have these properties. Initially, ceramic materials were used for the interconnect materials, but later low temperature solid oxide fuel cells use or modern SOFC use metallic interconnect materials because of a better electrical condition and low cost and easy fabrication. But these interconnect materials have some issues. Like the main problem is the corrosion and the chromium migration. So you can see over here, every metal, almost steel, every steel has a chromium layer at the top surface. When it is heated in SOFC environment, the chromium layer react with the oxygen and water molecules to have a chromium hydroxide, which is volatile in nature. It penetrates into respective electrode and decreases output voltage. So as the chromium oxidation increases, electrical resistance also increases, which decreases the fuel cell efficiency. So we need to control it. So from the previous research works, we concluded that different types of alloying element have been added, but it increases electrical conduction, and it decreases oxidation, but not significantly, so we cannot use it widely. So here we have another method of controlling chromium migration. So this one is a coating technique that have been used by different types of by different researchers and by different spanner layers, but none of them work significantly. I use the dip coating because it is a easier method. I decided to coat a layer over this surface. I will discuss this lately. So the problem statement is that the every ferrite, every steel has the chromium layer. Different types of alloying element has been added, but they fail to reduce chromium oxidation. So another method that used by different types of researcher, that is to fabricate a thin coating layer over the surface. But if we increases the thickness of oxide layer, it decreases electrical conduction according to this formula. So if we increases the thickness of oxide scale spinel layer,
I think we don't have any more presentation in this session. All the paper have been presented far away from the paper of Abdullahi due to the technical issue in the recording. Then thank you so much for your participation and for the sharing of your finding from your research. And in the name of Icper, we wish you the best, and hopefully we will meet you again in Icper 2022. Thank you so much. Okay. 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 Thank you so much. Wa alaikum assalam wa rahmatullah.